Oh, so that's mod n. If Jacobi symbol of x
Are you
mod
gonna prove
p.
it? You're trying to prove this? Statements used listed?
Yeah.
Okay. I'm thinking at this point a lot of people are actually confused with the details.
Oh.
How about we just keep in the application?
Okay, sure. That's fine. So yeah, we can talk about Jacobi symbol mod n. We've got the same sort of qualities as the previous one, except this time we have one added different quality. So the idea is that if you have two numbers that are quadratic residues and you multiply them, you'll still get a quadratic residue. And if you have two numbers that are not quadratic residues, but specifically are in the set of quadratic residues with the Jacobi symbol of +1, and you multiply them, then you'll get a quadratic residue. And if you multiply a quadratic residue times a number in the same set, the quadratic non-residues with Jacobi symbol of +1, then you'll get a special kind of quadratic non-residue, which also has the Jacobi symbol of +1. And we'll see why that's useful later. Now, okay, so this is the key generation algorithm for the Goldwasser-Micali crypto system. So basically what you want to do is, first, you're going to give it how many bits of like security you want. So this will basically be the size of the primes that you're going to generate. Prime generation, that's sort of a, basically you can do certain things to speed it up, but what it amounts to is picking a random number and checking to see if it's prime or not. And then if it's not prime, you pick another random number, and so on. But there are certain types of primes that are maybe more secure than others. And so also there's like different ways that people have tried to calculate these things. What I would do if I'm writing some code to generate some secure primes is just use the built-in functions. And then if you want to calculate some z that is a quadratic non-residue with Jacobi symbol +1, you're going to have to use basically the P and Q, calculate when you have something that has a Jacobi symbol of -1 for P and -1 for Q, and then multiply, or yeah, so you find a number that has -1 for both of those. So then the Jacobi symbol mod n is +1, but it's not a quadratic residue. And so then you send that as another part of the key. And what's useful about this z is that it allows the person sending a message to calculate numbers that are not quadratic residues without knowing the factorization of n.
Oh wait, sorry. At this point, I'm very confused. Can you give an example with some kind of numbers?
Sure. I actually have the code, so I'll just go get it.
Oh, nice. So yeah, guys, Pi Day. We're gonna throw. I wanna throw a pie in Zack's face. It's gonna be fun.
Can't object.
Yeah. Why? That's tasty.
That's his chocolate.
Okay.
Okay. I'll